reading and writing to files. We will focus on two types of files, text files and JSON files. This is the outline of this session, how to read and write text files, how to read and write JSON files. Let's start with text files, and let's first motivate why do we need to read and write to files. So as you know, when the program is running, we are manipulating variables, lists, arrays. Once the program closes, the program crashes, all these variables, all this data will be lost because the memory is volatile. Once the power is off, or if you close the program, all the data is gone. So that's why if we care about some data that we need in subsequent runs of the program, we need to store it, either in a file or a database. So that is the motivation. Now in Java, there are many ways of reading and writing files. It can even get quite confusing. So I try to select the most simplest and the latest way of doing it. And as you will see here, in few lines, we can do very powerful things using this new API. So the API I'll be working on, or the classes that I will be showing you, all of them, or most of them, live in Java neo.file. So the packages is living in this in the file. The classes and methods that we'll be using are implemented in this package. I think this was introduced in Java 8. There are many other ways to do the same thing, but I found this one to be the most elegant way and the simplest way to do it. So we'll be covering these four aspects. This is again big topic, but the practical side of it is what I will be covering in these few slides. So hopefully in one session we will be done with this. So the first thing is, if I want to get some information, more information about a particular path, I can call this get method of the paths class, and I'll show you some examples. For reading a text file, I simply use files.lines, very easy way to read the whole file, and then files.write, so write to a file. And if I want to list the folders or the files inside a particular path, or I want to find out what are the files and subdirectories in a particular path, I can use files.walk. So I will be explaining these methods and giving you some concrete examples. I try to do it as fast as I can because most of what you need for your project and for practical things you will be doing in this course, you will mainly use reading and writing to JSON. So I want to spend more time in JSON rather than spending time on text files. But still, being aware of this is very important. Okay, so let's get started with the paths class. So the path class has many methods. The most interesting one of them is paths.get. So I'll call this path.get, and this is a static method, which means I don't need to create an instance of files. I'll just call it directly. Give it some either a relative path or an absolute path. What is the difference between a relative and absolute path? So absolute, you get the full path from the start to finish. And the relative is basically relative to the current location where the program is running. So when I say relative, go to the current location of the program and then go down one folder and another subfolder, and you will find the file there. So what we have seen so far, most of the examples I have given you so far, they all use relative paths. So for example, in here, I have a relative path, data/members. So this is a relative path, which means in the folder where the program is currently running, there is a subfolder called data, and inside that subfolder, there is a folder called, or a file called members.json. Now, if I want to get the absolute path, this is the absolute path. So I can either use, it's highly encouraged to use relative paths, of course, but if I wish, I could use an absolute path. Yeah, this is an absolute path. So it gives me the full path from start to finish. Now, in a string in Java, if you have a backslash, you have to put double backslash. Otherwise, the string will not like it. Okay. Although we mean there is only one backslash, but when we write it in a string in Java, you have to escape it with the double backslash. It's clear the difference between absolute path and relative path. Relative means I don't give you the full path. I only give you the path from the current location where the program is running, and some subfolders beneath the location where the program is running. Where in the case of an absolute path, then I give you the full path. But this is highly discouraged, because if I give you this program, maybe you don't even have a D drive, maybe you only have C drive, and this will not work. So always try as much as possible to use relative paths instead of absolute paths. So what this paths.get allows me to do, it allows me to get more information. It allows me to get more information about a particular path. So let me show you. If I run this as an example, so here I specified paths.get, and I give it here a relative path. Now, once I give it a relative path, I can ask that path to give me more information about this particular path. I can ask it, please give me the absolute path. It tells me, although I only specified here the relative, I can get the absolute. Here is the absolute path. If I only want to get the file name, I only want to get the file name. I don't want to get the full, I only want to get the file name, I can do so by saying path.get file name. If I only want to get the folder without the file name, I can do so by saying path.get parent. If I want to get the root, which is the letter drive, I can say path.get root. Yeah? So I can get information about that particular file by using paths.get. And it has a lot more than this. So if I can say path.get, get file name, get system, what else I can do? Size, can I say size? No. Okay, I think this is enough. Those are the practical ones. That's it for the paths.get. You can say path.get, you give it some either absolute or relative path, and you can ask the path some questions, such as only give me the file name, only give me the path, only give me the root. Is clear, this first step? Okay, second one is if I want to read a text file from disk. Many ways of doing it, as I explained. One simple way of doing it is doing files.line. And what this will, then I will give it a path. So what this will go ahead and do, it will go to the file, start reading it, and create a stream out of the file. So I don't read the whole file in one go and put it in a list, which is a stream. As the lines are being read, they are given to me, and I can do whatever I wish with them. And because this is a stream, can you see it? Because this is a stream of strings, I can use all the stream methods that we have enjoyed before. I can use the filter, the map, the sorted, the collect, and so on. Very powerful. So while reading, I can process the files while reading it, which is very, very interesting. So let me show you an example here. So in here I have a text file, countries text file, and it has the name of the country, the region, and the population. Name of country, region, and population. And they are separated by semicolon. So what I want to do here, I want to read the file, this file, I want to read it one line at a time, and I want to filter only the countries where the region is Middle East. Yeah? Any country where the region is Middle East, I want to filter it. And the output, I don't want the whole line, I just want the name of the country. Yeah? So that's my goal. So the way I can achieve this, very, very easy. So all I do, I go, here is my input file, and here is my output file, because I want to read them from the first file, filter the ones I want, and then write them back. Yeah? Okay, so this is what's going on here. I take the files.line, this is a class built in Java, .lines, and I'll give it the path. I don't give it the string, it will not work. Let me just try it. If I just put here the string, it does not work. It expects a path object. How do I create a path object from a path string? Path.get, okay? Then this will create a stream. You remember, stream does not store any data. Where is the data coming from? From the file. So as it reads each line, it pushes the line to my program. And what I'm doing with each line, so I am filtering. In here, I am only interested to get the lines where the country contains this word Middle East. Yes? And then what I'm doing here, I take the line, I split it using semicolon. And this will result in an array with 3 elements: country, region, and population. I'm not interested in all of them. What I'm interested to get only the country name. So I split the string and I pick up the first element of the array that results from the split. Then I sort them. Then I sort them in ascending order. And then I collect them to a list. You are familiar with all these methods from the stream. Okay? Let me just, for now, comment this out. I will explain it later. Yeah. And yes, let me just comment all this stuff. All right, that's it. So if I do this, then I am done. All right, so let me just run this. That's it, here it is. I have all my countries that are marked as Middle East, region is Middle East. And then I have them sorted in ascending order. Yes, I have them sorted in ascending order. I achieved this with one line, which is file.line, and the rest I am already familiar with. This is stream operations. It's nothing to do with the file. In terms of file reading, it's only one line, files.lines, and I give it a path of the file that I want to read. And then while I'm reading, I am processing the file. This is for the reading. Now for the writing, if I want to write, all I do, I go ahead and say, let me just move this up here. Very easy again. I'll say files.write and give it the path, destination path, and then give it the list of string. It will go ahead, take that list and write it to the file. So if I go ahead and run this, you can see here I have this file here. All the countries that are the 18 countries are added here very easily. So one line to read, which is files.lines, and one line to write, which is files.write. Yes? Now, if the file does not exist, you can see here I delete this file completely, and I refresh to make sure the file is not there. And I run this program, I refresh again, the file will get created. If the file is not there, it will get created. Now take a look at this. If I open this one, I get my files. If I rerun my program, the file is already there. What will happen to it? It will be overwritten. It will be replaced by a new file. So this is the default behavior. The default behavior of files.write If the file is there, it will be overwritten. If the file does not exist, it will be created.
Why didn't it give an error because the file was not there and it had to read?
No, the file was there when I read. No, I don't read from the same location. I read from one file and I write to another. You see here, I read the input file is countries and the output file is Middle East countries. Yes, so it's different. Yes, clear? Okay, now there's one more scenario I want to show you. You see here, I have another set of text that I want to write to the file. You can see there how many lines I want to write to the file. 3 lines, line 1, line 2, and the final line. And then I'll go ahead and say, please go ahead and write for me this file. Write this content to the file. This is how I do it. Files.write. This is the destination file. And then this is the lines. Let me just remove this. Now, if I run this, to my surprise, when I open this, I don't have the countries. The countries are gone. And instead of the countries, what I'm getting? I'm getting these last things that I wrote. So the last list that I wrote wins and overwritten my original file. And definitely this is not what I want. Yes? What I really want is what? These lines to be what? Appended to the file, added to the file. So by default, if I just say files.write, that's the default behave out of the box. The default behave is if the file is there, it will be overwritten. If it's not there, it will be created. But in here, what is my intention or what is my goal? To add to the file, not to overwrite it. So luckily, the API gives us this option of doing it. So it's a little bit a long way. The way they have designed it is you create an array of type open option, and in this array you put 2 options: create and append. What these 2 options tell the file.write, it tells the file.write, if the file is not there, please go ahead and create it. If it's there, don't overwrite it. Instead, append to it. That's the idea. And then I take this options array and then I add it here as a last parameter of the write. So now if I run my program, I'll get the correct behave, which is I get all the countries followed by these 3 extra lines that I have added. So without adding this options array as the last parameter of my call, I will not achieve this behavior. Instead, as you saw before, the file will be overwritten every time I do file.write. So this is important to keep in mind. In case you want to append to the file, you need to create an array of type open option. This class already exists in the package. And then you say, these are the options I want. Create and append. Now, if I don't put create, I just put append, then if the file is not there, you will get an error. It will say to you the file is not there. But in here, I put 2 options. Create and append, which means if it's not there, create it. If it's there, don't overwrite it. Instead, append to it. Is clear? Yeah? Yeah. Same thing. If I move this here, take a look at this. If I move this up here, and then when I write even the countries, I put here options. Yes. And then if I run, what will happen is the content will not be lost. It was stopped here before, yes? And this was added. And after it, this was added. Thanks to this extra parameter that I passed. Is clear? Okay, moving on. I want to show you one little thing, to show you a little bit the power of this library, or power of this API. So I have here files.lines. It reads the file as a stream, gives me a stream of strings. And then I do map to int. If you recall, map to int, and here I'm counting the length of each line, and then with the sum. So this line, what this is trying to do, it's counting how many letters or characters I have in the file. So, and then it outputs this. I have 7,470 letters in characters in my data countries.txt. So it's very easy. Yes, it counts everything. Yes, you're right. So this is wrong. I mean, this is not letters. Maybe if we say characters will be more appropriate. Yep. Okay. That's it for reading and writing. For reading files.line and for writing files.write. And I showed you examples. Now, the last one I want to show you is how to list files in a particular folder and how to walk to folders and subfolders of that particular folder and subfolders and keep digging into the hierarchy of folders in a particular path. It can become very interesting. So let me show you here first what I mean. So for example, in Explorer, in Windows Explorer, if I go to a particular path, it gives me the files in that path. So I want to do this programmatically. I want to write a little program, I give it a path, and then it lists for me the files in that particular path. Or even more interesting, I want to walk into the subfolders and discover and find the files within those subfolders. And if there is a subfolder in that subfolder, I go inside it and do the same. So in the first scenario, if I just want to stay in the root folder, I use the files.list. If I want to dig into subfolders and so on recursively, I use walk. Yeah? So let me demonstrate both of them. So here is the path methods. Okay, let me give you some examples here. Let's just start with list. So I'll go here and say, please go to this location here and go to this location and find me any files. Let me comment this out. Go to this location, find me all the files, put them in a list, and then display how many files I have, and display the actual files. Okay, which location I'm talking about? The CMPS 255 content. So let me go there, run. Not very interesting. It found these folders here. 7 things it found, which is correct. So if I go there under the content, yes, that's what it found. 7 items. Can you see them? 7 items. And how many things were we found here? 7 items. Okay. So now if I say, please go ahead, go to the lectures and show me how many lectures we had. So I can go here, underscore lectures, and then I run. It shows 15 files were posted there, and here are the files. Yes? Okay, so this is already not too bad, quite interesting. But it becomes even more interesting when, you see, when I use a list, it just gives me the files, the folders, here, folders and files. But I want the program to go into each subfolder and tell me what's in there. So instead, if my goal is to do that, instead of using lists, what I will be using, walk. Okay, and then I run, and you can see there all the files that I have there. I can even, instead of just getting the file name, I will get the full path to see what's in there. I will get the full path. Here it is. You can see here the full path of every file I have posted. How many files we have? It was, okay, because I think we kept ourselves too busy. Okay, run. only 5,096 files were posted to GitHub on this course. Okay. Now, the most interesting ones, of course, are Java files. I can ask, please only give me the ones that have Java files. So I can say here, filter this stream and get the file name, convert it to a string, only give me the ones that end with .java. And if I run, yes, if I run, I will basically get, we had 240 examples. Okay? So this is where it becomes very, very interesting. You can walk through and find. I can find how many PDFs I've posted. PDF. I can say, give me all the files that have ends with the extension PDF, and it shows me we had 22 PDF files posted. Yeah, and so on. You get the idea. So list only looks at the current folder and the content of the current folder. And walk recursively visit every subfolder and subfolder all the way, all the subfolder hierarchy I have in the current in a particular path. And then the good news is the list or walk, both of them return you a string. And then because it is a stream, you can use all the stream operations we studied before, including map, filter, collect, and so on. Clear? Okay. That's it for files. Hopefully now you know how to read and write files and how to list and walk through the content of a particular folder. So the next topic I want to spend more time on is how to actually read and write JSON files. We already seen this. Hopefully this will be much easier now. You're already familiar with this. So in JSON, if you have a class and you have instances of that class, and you might have an instance, you might have an object at hand, and you want to store it in a file. So there are many ways of doing it. One of the best way of doing it is to convert it to a JSON string and store the string. This way you can read it very easily back to an object. So it goes from object to string and from string to object very easily using JSON. So initially, I showed you one library before called Json, which is a library from Google, which is good, but it has some limitations when you go to advanced scenarios. So it has two problems that I found. It does not support JavaFX properties. Remember JavaFX properties? When you write an object that has JavaFX properties, the way it serializes, it does not give you a clean serialization like this, or it does not give you a clean representation like the one you saw here.
So doctor, you mean if you store our data on JSON file, you cannot use properties, JavaFX properties?
No, you can. If you use JSON as it is, library as it is, it does not. You can use it, but when you take an object with properties and write it to a string, it does not look neat like this. It creates so many other stuff that's not necessary. Yeah. So a more clean solution, and more importantly, it does not support class hierarchy. Those of you who attended last session, I explained this and I will explain it again. Class hierarchy means I have, for example, let's say students and faculty inheriting from member. And you want to store all students and all faculty in one file. You just have one file instead of two files. So JSON will not help you, will not be able to read and write instances of subclasses stored in the same file. So that's why I explored this a little bit more, and I found this much better library, as easy to use as the JSON library, but it has this power of supporting both JavaFX properties and it supports class hierarchies. When you hear class hierarchies, I mean something like you have a member, and this member, you have, let's say, two subclasses, students and faculty. And what is your goal? Is to take instances of students and instances of faculty and store them in the same file, let's say members.json. Why are we trying to store them in the same file rather than putting the students in student.json and faculty in faculty.json? Why are we trying to store them both in the same file?
So we don't have lots of files.
That's one. It's not a big problem if we have many
And they
files.
have to write lots of code.
Yes, we don't want to duplicate the effort. If we have two files, we have to run two functions, one to read the student file and one to read the faculty file. And if somebody is looking for a member, we have to do two searches, one in the faculty, one in the student. So it creates some inconvenience and some code duplication. So it's nicer because a student is a member and the faculty is a member, it's better to put them both in one file. So to put them in both in one file, the JSON library does not support this scenario easily. It can support it with some extra coding. You know, in this course, although it might sound complicated in some parts, but I always try to find the simplest possible way. Although that simplest possible way sometimes can get a little bit scary, but we cannot help it. I try my best to put it the simplest possible way. Okay? So this is the simplest possible way. So all I do, very easy library, I create an object of type object mapper. I take the object that I want to write to JSON, and all I do, I go object mapper dot write value as a string. I give it an object. What does it give me back? A string. And this string will have the JSON representation of the object. That's it. Very simple. Even simpler than JSON. Yeah. Especially when it comes to files. In one line, what I'm doing here, I created an instance of the object mapper. And then what I did here, I went to this JSON mapper, read value, instead of read value basically, and I'll give it the path, the file that I want to read, and I'll say, please go ahead, read for me this file located under data surahs.json, and I want you to read it and read it for me as an array of surah. And that's it. In this one line, I convert from a JSON string file to a surah array. And if I wish, I could convert very easily again from an array to a list using arrays as list method. Yeah. So it's even simpler than JSON. In one line, all I do, object JSON mapper, which is an instance of object mapper, dot read value, give it the file you want to read, comma, what is the data type that you want to convert the object that you read? What is the data type? In here, the data type is an array of surahs, because in my file, I have an array of JSON objects. Yes? For the writing story is exactly the same, very simple again. Here is my instance of the JSON object, of the object mapper. Here is the file I want to write to. And then I'll say, object mapper, please wake up, write for me this value to this destination. And this is the array I want you to write. It goes ahead and writes it to the file in one line. So all we have two functions or two methods that the object mapper gives us. Read value, we give it the file and the data type to convert the object that we read. What is the data type we will convert them to? In the write, again simple, the object mapper dot write value. I give it the destination file, comma, the list or the object I want to write. And that's it, it goes ahead and writes to the file. Okay, so you can see it's very simple. To use it, you have to download 3 libraries. In here, you don't need to download them, just copy them from the existing project. It's highly recommended when you download to a lib folder within your project. And then you make your project aware of these jars, of these libraries. how do you make your project aware of them? You right click on your project and say Java build path, click class path, and add the jars that you have downloaded to the lib. This way, your program can make use of the object mapper library. Okay? It's very popular library. Those of you who attended yesterday, I showed you the popularity of this library. Okay. Now, if I compare object mapper and Json, both of them are very simple to use. In one line, you can read and write very easily. But the object mapper has two advantages. It has built-in support for classes with JavaFX properties. Second thing, it has support for inheritance hierarchy. And this is where I want to spend a little bit of time explaining this. So let me run it through an example. So what I have here from the last example we discussed last time, I have here a file called members.json. Let me show you first the hierarchy. What I have here is the member class. It has ID, first name, last name, email, and those are properties to be able to do binding on using JavaFX. And I inherited or extended this class in faculty, and faculty adds one extra property, which is office. And I have student, and the student extend the member with one property, which is GPA. So I have a hierarchy, the member being the superclass and student subclass and the faculty subclass. What is my goal? Is to store instances of both students and faculty in one file. And what is the name of this file? Members.json. You can see here, both of them are happily living in the same file. Here is one student, second student, and there is one faculty here. Yes? How can the object mapper distinguish between a student object and a faculty object in this file? But this little type, you see here, this JSON file, it adds this extra attribute to each instance, to each object in this file. Remember, an object starts with the curly brace and ends with a curly brace. This is an object. What is the type of this object? Students. How do I express this piece of information? By adding an attribute called addType student. And for faculty, exactly the same. You can see here faculty does not have GPA, instead they have office. Okay, and there is the addType, and the value here is faculty. Yes? Okay, let me show you the code that tries to read and write to this members file. Oh, here is the code. So what I have here, take a look. What I have here is, this is the file I want to read from. I put a relative path. Always try to put a relative path, not an absolute path. The reason why this program can be easily moved from one PC to another without problems. If I put here a B drive, my path, I give it to you, maybe you don't even have B drive. You only have C. This program will not run. So always try to put a relative path. In our program, in our example, it's a standard way, creates a folder, a root folder in your project, one for lib to put jars that you depend on, one for data to put the files that you want to read and write. Okay, and then I created an object mapper here, an instance of object mapper, and say, please go ahead, read for me this file, members.json, and I want you to, as you read them, create a member instance for each of them, convert them to a member class. Yes? Now, this poor object mapper will be so confused, because what I'm telling it to do, read each object and make it a member. Read each object and make it a member. Now, if I go to the member class, take a look at the member class. The member class is an abstract class. I cannot even create an instance of it. So how does the mapper know to solve this puzzle? I'm asking it to read from this JSON file, and I want you to create out of this file, create for me an array of members. But I cannot even instantiate member. I can, of course, instantiate either student or member or faculty. I cannot instantiate member. So if I just do it this way, this will not work. Definitely this will not work. So to solve this problem, the object mapper people, the people who created this library, basically gave us this extra annotation to help the mapper. Anyway, this brilliant idea that the syntax, sometimes they forget themselves and come up with quite complicated syntax. Could be expressed in a much easier way than this. But anyway, we have to sometimes be patient. So luckily, we just copy paste this. Copy paste it, and where you place it? On top of the superclass. And then what you do here, this one is exactly the same regardless. What I'm putting here, this one it says, oh, if you find the add type equals student, then create a student object out of it. If you find the add type equal faculty, which class should you use to create the instance? Faculty. So it's basically giving some hint to the object mapper saying, oh, I'm giving you some hint to help you map the add type value with the class associated with that value. Yes? So they could have expressed it in an easier way, but anyway, this is how they have done it. This is quite nice. I think this one is not that bad. So here it says subtypes. I have two subtypes. What are the two subtypes? Student, yes, student. The add type will be student. And for faculty instances, the add type will be faculty. So this way, the object mapper knows what to do. Yeah? And when it's, let's say I give the object mapper, please go ahead and save for me this student object. If I ask the mapper to go ahead and save this student object, so what the mapper will do will say, oh, because this is a student object, I will add one attribute, add type, and the value of that attribute will be student. How does it know that the value of this attribute should be student? From this annotation. From this annotation. If I give it a faculty object, say, object mapper, wake up, save for me this faculty object, what the object mapper will do? Will add one extra attribute, add type, and what will be the value? Faculty. How does it know that it must add an extra attribute add type and set the value to either faculty or student? Through this annotation. Because in a member, do I have an add type attribute? No, I don't. So, but in the file, do I have an add type attribute? Of course. Why do I have this add type attribute? Yes, to help the object mapper decide what instance to create out of this object. Because there's no magic. What the object mapper does, it's reading this text file and going one object at a time and creating instances either of faculty or instance of student. It cannot create instance of member. Why?
Because it's
Abstract. So now the object mapper will have some difficulty to decide, do I create a member or do I create a student? Sorry, do I create students or do I create faculty? Okay, it cannot bring its flower and says student, faculty, faculty, student, and then makes a decision. Okay? It doesn't make sense, yes? So how to help it make that decision very, very easily? Add this annotation. By having this add type inside the file, and how this add type gets added to my instance from the annotation. So that is the reason why we must have that annotation. If we remove it, it will fail immediately. Why it will fail?
Because we've added an extra attribute that's not.
No, that will be ignored.
That's abstract.
Because it is, yeah, thank you very much. Because it is an abstract, because the casting or the data type we are specifying in the read is an abstract class. Yeah, that's the reason why. Okay, so that is the idea. So keep this in mind and make use of it. For example, if in your project you might have an inheritance hierarchy, you might have vehicle, car, and truck. So instead of having one file for cars, one file for trucks, you can have one file for vehicles, and then you come to the vehicle class and add this annotation here, copy paste it, and change this to car.class, name will be car. Truck.class, the name will be truck. And this way, you have one file, and you have one method to read, one method to write. One to read, one to write. So I'll just show you the read and the write. Here is the read. Here is the read. We already seen the read. Here it is. The read, we already seen it, read value. And you can see here I cast it to member. I'm making use of polymorphism. Remember polymorphism? An array of member, I'm storing either student or faculty. Now for saving, same thing, exactly the same thing. Here is the destination file, and I'll say, go ahead and write. Yes? Go ahead and write. When I go ahead and write, it will take the file, it will take members. Can you see members? Which is an array of member. It could be either student or faculty. Okay. Now for writing, I can optionally, if I wish, I can ask it to use the pretty printer. What is this pretty printer doing? It's not writing it in one line. It's writing it nicely in like this. Can you see here? It's writing it one object at a time, and each attribute is its own line. If I don't use this pretty printer, it will write all as one line. For program, it doesn't matter. It even likes it that way. But for us to read it, if you open it in another editor, it's much easier if it's written this way. So if you wanted to write it with nice indentation and nice format, you instead of, before you say go ahead and do the write, you say, please, when you're writing, use the pretty printer. That is the idea. Okay? That's it. So let me just summarize what we have seen. This is the last thing. So we've seen path. I can refer to a particular location. And once I create a path out of this, I can ask it questions. Give me just the file name, give me just the path, give me the root path. It's very useful. Reading the files, I do files.line. This will give me a stream of strings, and I can process that string using string operations. And then in terms of writing, I go file.write, and I give it the destination path and the list of strings I want to write. If we want to do append, I need to pass in the options. Create and append options. Printer writer, sorry, I didn't cover this one in one line, very quickly. Printer writer, not very interesting. If you want to do some formatting of what you want to print, you can create an object of type printer writer, and then you can basically do out.printf, and you can use the formatting of the string.